How are you, my friends? This is Calculus 1 Solve Questions. In this video, we will find some limits by applying L'Hopital's rule. And this is part 1, so you can expect part 2 and maybe more. Question number 1, find the limit of 1 minus tan of x divided by 4x minus pi as x goes to pi over 4. First, we check the L'Hopital's condition. So if we replace x by pi over 4, this will be 1 minus 1 over 4 times pi over 4. So it will be pi minus pi, it will be 0 over 0. So the condition here applies, so we can apply the rule. Let's find the derivative of the numerator here only, divided by the derivative of the denominator. So the derivative of 1 is 0. The derivative of tan, see this is tan of u, it will be secant squared of u from lecture number 11 times du over dx. And here we have only x, so it will be secant squared of the x, and there is a minus in the question. The derivative of 4x is 4, and the derivative of minus pi is 0. So now we can replace x by pi over 4, secant pi over 4. This is 1 over cosine pi over 4, which is square root of 2. You square it, so you get here 2. And there is a minus, and there is a 4 there. So the answer will be minus half. Question number 2 is really an interesting question, where we have to find the limit of 1 minus cosine square root of x divided by x, as x goes to 0 from the right side. But in the question, he said, without applying L'Hopital's rule, find the limit. You can find the limit by L'Hopital's rule. It's easy. But we need you to find a way or a method without applying L'Hopital's rule. You can try it yourself if you like. Here what we do is we try substitution first. So 1 minus cosine of the 0. Remember here, square root of x. That's why we have 0 from the right side. It should be positive values of x. So 1 minus cosine of 0 will be 1 minus 1 over 0, so it will be 0 over 0. So we have to rewrite the given, we have to do something. So we can start by letting square root of x here is equal to u. We change the variable. Square both sides, you will get x equals u squared. So every x here, I will write u squared, and every square root of x, I will write u. So that's the question here now. So x goes to 0 from the right side. So that means the square root of the 0 will be also u goes to 0 from the right side. So 1 minus cosine of u divided by u squared. I can multiply up and down by the conjugate. You see, 1 minus cosine of u, the conjugate will be 1 plus cosine of u up and down. In the numerator, I will have difference between two squares, 1 minus cosine squared of u. And I can replace it by sine squared of u, because I know sine squared of theta, any angle, plus cosine squared of the theta is equal to 1. And here I leave u squared, I leave the bracket 1 plus cosine of u. Now I can rewrite again sine of u divided by u all squared, because I have squared here, squared into u. And here I have the limit 1 over 1 plus cosine of u. This one is 1. We know that. So that's 1 squared. 1 over 1 plus cosine of the 0, which is 1. So the whole answer is half without using L'Hopital's rule. Question number 3, find the limit of x squared divided by e to the power x as x goes to infinity. Now, to find the limit, we need to check the L'Hopital's condition. So x squared, if x goes to infinity, it will be plus infinity, and e to the power x as x goes to infinity will be also plus infinity. So the L'Hopital's condition is satisfied. So we can use L'Hopital's rule. The derivative of the numerator divided by the derivative of the denominator. So the derivative of x squared will be 2x. And the derivative of e to the power x will be e to the power x. Let's check again. x goes to infinity, so 2 times x will also go to plus infinity. E to the power x will also go to plus infinity. So the condition also, L'Hopital's condition again, is satisfied. So we can apply the rule again. It will be the derivative of 2x divided by the derivative of e to the power x. This will be 2 over e to the power x. Now x goes to infinity, so this is growing very large. 2 over infinity will be 0. So 0 is the limit of this given question. Question number 4. Find the limit of e to the power x divided by x as x goes to infinity. You can try it yourself if you like. Let's check the L'Hopital's condition. E to the power x, if x is going to infinity, it will be plus infinity, and this one will be also plus infinity. So we can apply L'Hopital's rule. The derivative of e to the power x is e to the power x. The derivative of x will be 1. Now, this is the final step here. Limit of e to the power x, x is going very large to infinity, so it will be plus infinity. So we say the limit does not exist because there is no specific number. Now, for more questions on L'Hopital's rule, you can see lecture number 21 and also part 2 and more of the Calculus 1 solved questions. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.